So, welcome to this next session where we will start looking at the control flow statements and then later the loops. So, let's get started. Okay. So, basically, control flow statements. I mean, as like in any other system, right? In a C program, the execution normally goes sequentially. Like the execution control will start in the first statement of main, and will keep going in steps. Like every statement after every semicolon, then statement ends. The next statement will go on. Now that's a logical flow. If I have a simple logic, I can just keep writing all my statements and then get the output that I want. But often you may want to take some decisions, check some conditions, do some things differently based on the conditions. That's quite common in programming, right? So that's where you need the control flow statements, just like what we saw in the assembly level, where you have the jump and branch statements based on the conditions. So you need those are the same things that are coming into the high level language also, the same concept. And in fact, when these statements are when you write this statement in C, finally it's implemented in the assembly language using some of those primitives which are available. So basically, we'll look at some of the conditional branch statements like if, else if, and then switch case. Then next is iterations, where if you want to do some things in a repeated fashion, right? We saw some examples about adding numbers. So you don't write the code to add 100 numbers 100 times, right? You can write once and intelligently try to reuse that code by using some appropriate parameterization. So that is called iterations and loops. Well, also things looks like nested loops. There are different types of loops like while loop, for loop, do while loop, and all that. And there are some things to either come out of a loop under some conditions, or to skip some part of the loop. They're called break and continue statements. And there is this go-to statement which is available, but generally it's not a good programming practice to use it because it kind of makes it difficult for somebody to understand the code when you have a lot of go-tos. It's used in very, very rare cases, but it's there as a completion sense actually. So this is the broad topic for this module. Okay. So now let's look at what are control flow, right? I think so. As I said, the statements specify the order in which computations are performed. Like basically, they kind of take the flow and then they change it. So again, just to recap, we saw in C each statement is this is a single statement which ends with a semicolon. Okay, and you can have a group of statements like this, and if you group them together using this curly brace pair, right? So this is sometimes called as a basic block. This whole thing is sometimes called as a basic block or a compound statement. Okay, so this is called as a compound statement, and generally program execution is nothing but execution of these statements in sequence, right? Okay, it's a single statement or a compound statement. It is start from the top and it keeps going down. You open a C program. The order in which it happens is starts with main, first statement, second statement, so on. You make a function call. You go to that function. There it goes. In return, you come back here. And if there's a conditional statement based on the condition, either it's met or unmet, you will take multiple different paths actually. So that's how a C program typically runs. So we'll now look at some of the control flow statements. So this concept is important to understand. A group of statements is called as a compound statement because you will see that syntax in many of these things actually. Okay. So the first and the simplest one is the if else statement, right? Okay, which means you have a condition. If the condition is true, you want to do some things. Else, do something else. Okay, that's a basic simplest form of if else. So we check a condition, then do it. If tank is empty, pump motor, right? Or if something is there, turn on the light. If it is dark, the the sensor is saying, the light, ambient light is less, turn on the light. Something like it's a very simple step actually. If condition, statement one, else statement two. So the way to understand this is where this thing is important. So I'm saying statement one here, right? A statement one can be just a simple statement like x equal to 5 or something like this, or this can actually be a group, can be a compound statement where I can have multiple individual statements. Okay, so in all the syntax description you will see whenever you see statement, you can imagine it can be a simple one-line statement or a group of statements. If you add only one statement, this curly brace is not required. So if I can just say if x greater than 5, I can say z is equal to x, else z is equal to 100 or something like that, some logic. So if I'm just saying one statement here, this syntax is fine. So if this is true, this will get executed, else this will get executed. But if I want to do more than just one statement, I need to put a curly brace pair and group things there. So basically, from a syntax perspective, this is also a statement. I mean, a statement can be a simple statement or a compound statement. This whole basic block is treated as a statement. So it's easy to understand. Once you know this, if you see the syntax like this, it's easy to remember. Wherever you see statement, it can be one line with a semicolon or a curly brace pair. Inside that, any number of statements. There's no restriction on that. Okay, so this is the basic if-else syntax. So most commonly used, you will see in almost even the most trivial program will have some if-else actually. So I already talked about it. Statement one, statement two can be simple basic statements or a compound statement, which is a block. And the else part is optional. I may have nothing to do with else. I will just do if something, do it. Otherwise, I go on and do other things, right? So the else part is not mandatory. I can just have if x less than 20, I can just say z is equal to -1, and then here I can have normal statements x equal to 5 or something like that. So if this is true only, this will get executed, otherwise execution will fall out of this. After the if statement will come here. So the if statements, technically this is all the if statement is. If I have if else, I can have something like this, else. So this whole entire thing is called the if statement. The if statement ends here. Can you see that? This is the end of the if statement. So after that, the control will continue to execute actually. Okay. And so basically the operation is as we described. The expression is evaluated. So this is the reference to this slide. So if expression, right? The expression is evaluated. If the expression is true, evaluates to true, which is mean any non-zero value. Okay. As I said in C, anything non-zero is considered true. If it is a non-zero value, statement 1 is executed. If it is false, which means it's a zero value, the else part is executed. Statement 2 is executed. That's the basic operation of an if-else statement. There can be nested, like nested statements. Just to give an example, like you can. I can have some kind. I can do one check maybe, right? I will just check if x greater than 20, right? Then I start my block. I do some things like y equal to 5 or something like that. Then I again check if z is also greater than x. Then some more things. So you can have any level of nesting. So after this, it's like this is just like another if statement actually. And the curly brace ends here, and then this curly brace can end here. In both these cases, we have not put an else. If there is an else here, this matches the previous this thing actually. So this else is part of this if. And after this else is over, you put this final curly brace here actually. So this is how the statements can be nested. If statements can be nested. Okay. And the thing is, since else part is optional, right? Any ambiguity is resolved by associating the else to the closest previous else-less if. Like basically, since else part is optional, you suddenly see an else to which if it has to pair, right? It is the closest one. You go up, whatever is the closest if without an else, that is where it matches actually. So that's just to make sure the ambiguity is resolved actually. So just some examples like see if x greater, we have declared 3 variables, x equal to 2, y equal to 5, z equal to 10. We're just printing 2 different messages. If x greater than y, print x is greater than y, else print y is greater than x. So these are examples with just simple statements. If has one statement, else has just one statement. So there is no need to put the curly braces in this case. So though some people, depending on the coding standards, right, some organizations say it's always good to put curly braces because sometimes otherwise that else-less if it causes some confusion. So as a good programming practice, many times, even if it is just one, sometimes people put curly braces. Nothing wrong about it. So it makes it very clear and there is no confusion. So, but the language is okay. If you just have one statement, there's no need to put a curly braces. But many organizations, their coding standards will tell, coding standard is nothing but a standard way everybody follows, so that in an organization it is easy to read another person's code and maintain it better. So sometimes they say it is always good to put the curly braces. It depends on the organization actually. As another example, you can see that here. Like here, the only difference is we have put this curly braces because we are doing multiple things here. If x is greater than y, I am assigning x z equal to x, else I am saying z equal to y. So what is the logic? This is just essentially assigning z to whichever is bigger, x or y. It compares. If x is greater than y, it assigns x to z. Else it assigns y to z. So basically, you can say at the end of this code snippet, z will have the maximum of x or y. So whichever is the maximum value will be stored in z. So it's a simple logic which you can implement using a very simple if else kind of a logic actually. And here we have used both the both of them have a basic block kind of a compound statement. So that's why you have the curly brace pair here. So these two are part of the if condition, and whatever is there between these two, this is part of the else condition. Okay. And then there is something more general form is called else if. So we just saw one if and just an else and something, but you can keep checking. You may want multiple things to check, right? So I may first check something, do something else. If something else is true, do something. You can keep moving like this. So this is case of a complete, this is called else if condition, else if format actually. If, else if, and go on. And finally, you may have one else, which is like if nothing is matching, kind of do this. It's like a default thing. If none of the conditions are met, so this is going to happen at the very end actually. So this comparison will keep going in sequence. One thing to remember is, say, if this expression matches, once this is executed, the whole if loop will end. The control will come here and will continue here. Okay, so that's how the logic works actually. Okay. So in the above sequence, that's what I'm saying. Expression 1 is first evaluated. Okay. Expression 1 is first evaluated. If expression 1 is true, statement 1 is executed, and this terminates the whole. It won't keep checking. It will do that and it will come out of the whole if loop actually, if condition. Else it will go to the next condition, expression 2 evaluates it, and if it is true, execute statement 2 and terminates the change. So this continues, and if none of the if clauses evaluate to true, that is when the final else clause will be executed. So understanding the flow, right? So basically the moment one of these expressions in this chain will start from 1, 2 in sequence in the way in which order which you have written, the moment one of them is true, it will execute that statement corresponding to that expression, and the whole if condition, if statement is completed. Actually, it will go if there is some statement after that, after the final else, execution will continue here. So that's something important to remember. So you can see this logic here. There are two variables. We are saying if x greater than y, we just print saying x is greater than y. Else, if y is greater than x, say print y is greater than x. If nothing, then we say x is equal to y, because if it is not greater or not lesser, I mean, then the only possibility is it has to be equal. So this is a way to write the if else if kind of a construct to achieve the logic that we want to be implemented. So this is the basic if else logic actually, which is quite intuitive and easy to understand. We saw some examples as well. Then the next type of control flow change is called the switch statement. Okay, so it is again used to, it is typically used for a multi-way decision, and it's convenient to use it in some scenarios. We'll see some one or two examples. Okay, but here there are some differences. The way it works is you give this syntax. The syntax starts with this keyword called, this is a keyword. If, else, switch, for, these are all called keywords. These are reserved words, which means you cannot have a variable by the same name. And probably I forgot to mention earlier, variable names cannot start with a number. It has to start with an alphabet. Generally, good practice to use alphabets, and maybe numbers can come later. Sometimes you'll use underscores in between. So other characters, some modern versions of C allow, but in general, it's a good practice to stick to just numbers and underscore. Sorry, names and then underscore. Where needed, some numbers in some cases actually. Okay. And so the syntax here is you put the keyword switch, and within this thing brackets you have this expression. Okay. Now what happens? The way it works is this expression will be first evaluated. Okay. And then you will have a curly braces, and you'll have a series of case and some constant expression. So what do you mean by constant expression? These expressions should finally evaluate and give you a constant value. Okay, that is the constraint for these expressions here. So this expression will be evaluated, you'll get a value. So on that value will be compared with these constant expressions, and say the first one matches. If this matches, then this statement, there can be a set of statements here that will get executed, and moment something matches, it will continue to execute all the other statements. It is slightly different from a if condition in this way. In if one condition matches, you come to the end of the if statement, right? Here in case, it will keep checking. The moment something matches, it will execute the statement starting from there, and all statements after that also will get executed. So if you don't want that behavior, you want to execute only statements associated with, say, the first matching thing. What you need to do is you have to put this word called break at the end of whatever you want to do there. If you put a break, then it will come out of the switch construct actually. Typically that's how we use it, but there are some cases where you want to let it continue for some time. We'll see some probably examples of that. So this is the basic structure, and finally you have something called a default case. If none of these things are matching, then this gets executed. These set of statements gets executed. So that's like a default. If nothing matches, earlier matches, it comes to here, the last thing, and it executes that. So this is what I talked about. Expression is evaluated, and it needs to generate some kind of an integer value, and the constant expression is compared with the expression value. And if anything matches, set of statements are executed, and execution continues after that. That is called fall through. So say third case matched. After the third, everything will get executed. First two will not get executed. Third case, whatever matched, from there everything will get executed. So that's why we need an explicit break statement to exit the switch case if that is the desired behavior. Usually that's how we do it, but there are some cases where we let it continue also. Sometimes we may want to do a same action for multiple conditions. We will see some examples, right? You can write some code where for 2 or 3 conditions, I want the same piece of code. In that case, you can actually kind of group them together. So it is almost like, in an if statement, if you're writing if this or this or this or that and do something, right? It will be very similar to that. We'll just see some examples actually. So the first expression doesn't match, it goes to the next expression and then compares with that. And then if the logic matches, it continues from there. So we'll just see a simple example of that here. So for example, you can see this thing here, right? So I have a variable int x equal to 2, and I have a simple expression switch x. So this will evaluate some integer value, and I'm comparing with, these are all the cases that I have written, case 0, 1, 2, 3, 4, 5, and so on. So what happens is when the switch statement is executed, this expression will be evaluated. This is a simple expression. The value of this is 2, right? Now this 2 will get compared with first 0. So it will go in sequence. Does it match with 0? No. So it goes next one. 1, it matches? No. It matches with 2? Yes, it matches with 2. And it will start executing from here. So though around 2 there is no instruction, but doesn't matter, it will fall through. It will come here. And you can say here, what are we printing? printf x is less than or equal to 3. So this is the reason where you allow that fall through to happen. For both 2 and 3 or anything 0, 1, 2, 3, any of these things matches, the first statement which is going to get printed in this case is this statement. And what are we printing there? We are saying x is less than or equal to 3, which is correct, right? So these are the cases. So this is what I said, right? It is almost like writing. If you have to give an analogy, it is almost like saying x equal to 0 or x equal to 1 or x equal to 2. This when you fall through, this is the behavior. For any of these things, you finally come and execute this, right? So instead of writing an if statement like this, you could have written this case statement. So I'm just trying to give you an analogy of how to view this with an equivalent if logic. And then after this, you just put a break. So the moment you see a break, control will come outside the switch loop. The switch starts here and it kind of ends here. So this break will make the execution come here. The switch statements ends with the last curly brace. Okay. So the curly brace, the line where you have a switch, you put a curly brace and there's the ending curly brace. So when this break is encountered, control will come out of the switch case expression. So it essentially comes after this curly brace here. Is that clear? Where execution transfers. Otherwise, then okay, if say 0, if the given value was say 4, right? 0 will not match, 1 will not match, 2 will not match, 3 will not match. It comes to 4, 4 it matches. And then execution will start from here. There's no associated date instruction here, but it'll come to the next one and find wherever is the next instruction. It is here after case 5. So now what are we printing here? Can you see x is either 4 or 5, which is correct, right? So 4 matched, you will print. Even if 5 matches, the same thing is going to get printed. And then again, we have put a break so that you want to continue. If say none of these things matches, suppose we gave 10, right? Case 0, 1, 2, 3, 4, 5, nothing will match. So it will come to the default. Default will match for everything. If it comes to default, the code associated with default will get executed. And what is it printing? It is just printing a message saying x is greater than 5. So which is correct. Do you understand? So this is how you use a switch case statement to group things together and take common action. So the only thing is, yeah, these are has to be constant expressions, and you have to compare and then take a decision actually. So this is we'll probably just take a look at some code examples and maybe just a couple of minutes we'll see a few examples of the if and case statements, and then we'll probably close this session for today. Just let me. Yeah, let's take some simple examples of if statement, right? Let's just take. Just simple. We are just doing a simple if statement, if and else. Okay, it's just 3 variables. I'm just comparing them and I'm just trying to print some messages. So let's run this. Okay, so x was 2, y was 4. So x greater than y is not true. So which means definitely the only other possibility is y is either greater than or equal to x. Okay, that's how it is. So we can, if you want to add an else if kind of a condition, we could have done something like this. If you say x is, you could have said right. So if I run the same code again, right now, so I messed up. So now it's saying y is greater than x, which is correct. Suppose I made y is also 2, it should now match the second condition. It should say y is equal to x. Or if this was say 1, it will say first condition will match. It will say x is greater than y. Is clear? So the same thing, just take a quick example of switch case, right? Let us say switch, I'll just say x in this case. Let's say case 0. Let's see. Hope there are no grammatical mistakes. Can you see what's happening here? Like we wrote a code like this. So x is having the value 2. So you enter this switch case statement. So 0 didn't match, 1 didn't match, but 2 matched. So it printed x is less than or equal to 2. But as I said in the switch case, after one matching case, all the other statements also will get executed. If you don't want that behavior, you have to put a break. In this case, we didn't put it. So this executed. And then the next statement here, x is less than or equal to 4. And here it's saying x is greater than 4. Obviously, this is not meaningful because, right, we are saying x is equal to 2, then we're suddenly saying x is greater than 4. So the right way to deal with this is to put something called as a break statement here. Similarly, it's good to put a break statement here also. So this is okay. 0, 1, and 2, I'm printing a proper message. So I can group them together. So let's see how it works now. Now it just prints x is less than or equal to 2 and it breaks, right? And to see where control comes, it will come here. To understand where after the next, what is the next statement executed, will be here. To say out of switch case. You see that after printing this, it comes here, okay? Now suppose I change the value, I make it say 3, right? If I make it 3, you can see 0, 1, 2 didn't match. 3 matched. There's no associated thing with 3. The next thing is 4. So it will now print x is less than or equal to 4. And there's a break again here. So because of this break, it comes here and it prints it. Now if I had given a value something like say 10 or 20 or whatever, right? Obviously the only thing it is going to say is x is greater than 4. Is that clear? How we can use switch case to group things together and so on. So this is commonly used in a lot of programs to compare values and easily take different decisions actually. Sometimes you can compare a character also, like you can, because character nothing but ASCII value, you can put a character variable and give the actually in character constants. Common way to do it would be something like this. We will say char c something, like you can actually have some value here. And then here instead of doing that, we can say a. Say x is either a, b or c or something like that. Something like that we can do. And then we can put just for some you can say unexpected value of x, something, just to show how to. Basically, these are also ultimately what you understand. It's when you write within h, right, ASCII value of h is what is stored. So it's also an integer kind of a constant. So that's why you can compare things like this here. So if I put h, it should now say x is either a h or a w. It's saying h is h or a w. Suppose if I had made it as say b, the second case should have matched. It now say x is either a, b, or a c. Is that clear? How we can use character constants also to do similar comparisons actually. Okay. Now let's move on. I think we'll cover the other things, right? So break is we have covered already. So I think we'll stop here. I think we have logically completed the basic control flow statements. So the next would be the loops. Actually, we will start with loops in the next session actually. So we'll end with basic if, else if, and switch here. The next group is called the iterations or loops. So there are 3 types of loops which we'll see in the next class.